Assalamu alaikum everybody. We are here with another session, Ultra Max Pro, and this time we have AdMaths. I'm really grateful to Sir Talha Fazal for joining us today. Sir Talha is a graduate of National University of Singapore, which is a very highly ranked university, and it takes a lot of hard work to get in. And not just that, he has been teaching for quite a long time. He teaches IB, he teaches A levels, he teaches O levels, add maths as well as the regular maths and all the other kinds of maths that we study in schools. And he does an amazing, like, exceedingly good job in all of them. He's based in Lahore and currently associated with LGS. I'm really grateful to Sir Talha for joining us here, and I hope that this session will be very productive and very helpful to you. Thank you so much for joining, sir. Please take it away.
Thank you very much. Pleasure is all mine. Hopefully this will be a productive session for everyone who's actually here. So if there are any questions from any one of you, so we may begin with the questions because this is how I normally would like to proceed. All right, Musa, do you have any questions? Right, velocity vectors. Right, let's say you're given a displacement vector as 0, 3 plus 1, 7, t. Now, Musa, can you help me explain, or do you know how to find the velocity vector from this? If you have any idea? Okay, you don't understand velocity vector in general. Okay, do you understand vectors, what they are? Yes, Musa, do you understand what vectors generally are? Okay, let me just try and give you an overview of what we are dealing with here. So displacement to velocity to acceleration. So if you try and differentiate, you get, if you try and differentiate displacement, you get velocity. And if you try and differentiate velocity, you get acceleration, right? Obviously, the other way around is also true. If you try and integrate, you get from acceleration to velocity. And if you try and integrate velocity, you get back to displacement, right? I hope that you know this much, right? Now, obviously, if let's say you're given a displacement vector, or in fact, let's just take an example of a velocity vector. Let's say you're given 3, 5 plus, I don't know, 7, 2, t. Now, obviously, this 3, 5 is what we consider the initial velocity. How do we figure out the initial velocity? I'll explain it in just a minute. And this is what we classify as the acceleration as well, because obviously this is dependent on time, and this being added with velocity, so it becomes part of the acceleration. And I'll just explain it in just a minute on how we actually try and do it. Now, how do we find the initial velocity from this vector? Is obviously initial velocity is when time is 0. So you substitute the time as 0. So the velocity will become, or the velocity vector will simply be this, right? So this entire thing, which you see here, 7, 2 multiplied by 0 become 0, and we'll only be left with 3 and 5. Now this 3 and 5, you obviously can find the modulus of this velocity by doing v is equals to 3 squared plus 5 squared and square root. You can find the initial velocity as square root of 34, and you can calculate this using your calculator, and you get the value of the initial velocity. Yes, Musa, does that make sense? Mariam, we are currently doing velocity vectors. G Musa, do you get up to this point? Yes, I mean, this itself is speed, obviously. Square root of 34 represents speed, which is the magnitude here, right? So now we can move on and try and find out, let's say, the velocity after 2 seconds, or let's say 3 seconds. So we go back and we see the vector is 3, 5 plus the vector is 7, 2 times 3. So when you try and simplify this, you get 3, 5 plus, obviously this is scalar multiplication, so this becomes 21, 6. And you can rewrite this as 24, 11 as v. Again, finding out the speed, you can find out the magnitude of this. You get 24 square plus 11 square square root. So this gets you, I think, 697, or square root of 697, which is going to be the speed. Right? So this is how you try and find out or work with velocity vectors. Let's say I need to find the acceleration from here. Now, obviously acceleration is dv by dt. I had the initial vector, which is 3, 5 and 7, 2 t. And I need to differentiate this entire thing with respect to time, right? So let me just try and rewrite this. So I need to differentiate this with respect to time. So what do I end up with? Obviously, this portion initially written here does not have a t with it, right? So the differentiation of this will simply be 0. The differentiation of t is just going to be 1. So you'll end up with acceleration as 7, 2. The velocity, the acceleration vector is going to be 7, 2. If you're asked about the magnitude of acceleration, you'll simply do 7 squared plus 2 squared square root, which is going to be square root of 53. This is what you have when it comes to velocity vectors, right? I mean, it works the same way. We are just working with vectors. That's the only difference. right? G, anyone else with any other topic that you would want me to go through? Apart from this velocity vectors, anything that you need clarification on? All right, if no other questions, then I have a couple of questions for all of you. All right, let me just try and share my screen and you can try attempting those questions. Right, so you have a question on your screen. These have been taken from some of the past exam papers, so you all can actually try and solve these as we go along. All right, Zainab, I'll try and cover permutations, combinations, as well as linear law as well. So if you could all just try and attempt this question that you see on your screen first, and then we can actually try and move over to permutation, combination, and linear law. G, do we all know how to solve this, or do you want me to actually start solving this for all of you? Okay, let's just try and solve this together. So the first thing that you actually notice here is that the angle is given to us as y minus pi by 4. So instead, we do need to change our domain for the angle as well. So what happens here in this case, you have to subtract pi by 4 just so you can make this angle as y minus pi by 4 as well. And this becomes pi minus pi by 4. So this becomes negative pi over 4. This is my y minus pi over 4. And this gets you 3 pi by 4. Now, what you're given here is cot squared, right? In order for us to actually change cot square, some of you may actually try using cos square over y minus pi over 4 over 3 sine square y minus pi over 4 equals 1. Then you can cross multiply, you get 3 cos squared y minus pi over 4 is equals to 3 sine squared y minus pi over 4. The 3 and 3 can cancel. In fact, there won't be a 3 here. It will just be in the numerator. So now you can actually try and divide the cos on the other side, and you'll end up with tangent square y minus pi over 4 once you divide both sides by cos square. Now, there's no right or wrong approach, but some of the students actually try and go through this process, which is something that I do not prefer or actually teach to anyone, all right? Because this wastes time. So the best way is that you can simply try and change right at the very beginning when you have cot, right? You can simply rewrite this as 3 over tangent square y minus pi over 4 is equals to 1, saving yourself some time. Because most of the students do struggle with time management. I mean, if you actually do know some of these shortcuts, it basically helps you a lot. So in the end, you'll actually end up with the same equation, which is this, right? Which is what we got by using cos square and sine square as well, right? So I'm just going to delete this from here so we can actually continue to solve this. Just give me a minute. So we had figured out the equation simply becomes 3 is equals to tangent squared y minus pi over 4, right? Now, obviously, this I will rewrite as my alpha. So my tangent square alpha is 3, or I can rewrite as tangent of alpha is square root of 3. All right. So once you try and find out your basic angle, it will be tangent inverse of root 3, which is going to be pi by 3. Now, obviously, I'll have two values. One is going to be negative and the other one is going to be positive. So first try and solve for positive values of tangent. So since the angle is pi by 3 and you have pi by 3 here, I need to see if it actually falls within the range. So if I look at it closely, this is 3 pi by 4 and this is negative pi by 4. So once I measure this angle, this is okay. So I can rewrite y minus pi over 4 as pi over 3. So that's the first angle done. The second angle is actually bigger than pi, but this value here is actually smaller than pi. So I cannot possibly measure this angle, right? So what we'll try and do is check from the other side for the positive angle. So this was pi over 3. Let's try and check it from the other side. I only need to go until negative pi over 4. So I can't possibly get the second angle or the second positive value either. Now I need to do for the negative quadrant. So tangent is negative here and here. So this angle is pi by 3 and this angle is pi by 3. Now when I try and measure the angle from here all the way up to here, this will be 2 pi over 3. And I won't be able to get the other angle because it actually goes outside the domain. And this angle will be negative pi over 3. So in the end, you'll end up with 3 solutions. So you have y minus pi over 4 equals negative pi over 3, pi over 3, and 2 pi over 3. And then you can add pi by 4 to all these 3 angles to get the desired results. Right. So this was the first part of the question. Let's try and move our focus to permutations and combinations. I'm going to stop sharing the screen and we can try and solve a question. I'm just going to make a question as we move along. Let's see if you can actually try and understand this. So let's say we are given we are given all 10 digits, right? And we need to find out numbers that are, let's say, that are odd and greater than 60,000. I mean, this is one of the common type of questions that you get when it comes to permutation and combination. We have seen that he might ask you about odd numbers, or he may even ask you about even numbers as well. So in this case, we are going to discuss on how to actually find out these odd numbers which are actually greater than 60,000. So there are two ways you can actually approach this problem. All right. So since we are looking at numbers which are actually greater than 60,000, one thing that I should specify here is we are only looking at 5-digit numbers. All right, we are limiting ourselves to 5-digit numbers. Otherwise, the problem could be fairly large. Right now, since we are looking at 5-digit numbers which are greater than 60,000, we have two restrictions here. The first one being the first number, and the other one being the last number. Now, in the first space, we can have a number which can be 6, 7, 8, or 9. And similarly, since we are looking at the odd numbers, at the last position, we can have either 1, 3, 5, 7, or 9. So now if you look closely, 7, 9, and 7, 9 are both repeated, right? That means we have to actually solve them separately. So let's try and solve with the even number at the beginning first. So we have even number at the start. So it could either be 6 or 8. So we have two options here. And then the last one can either be 1, 3, 5, 7, or 9. So how many ways can I actually fill out the first spot is just 2 ways. How many ways can I fill out the last spot is 5 ways. So I have chosen, or I've selected two numbers so far. Let's say it is 6 and 7. So I'm left with 8 other numbers. So I can fill this spot with 8 ways. I can fill this spot with 7 ways and this spot with 6 ways, right? So this is when you have, these are the number of ways you can actually fill, or you can get odd numbers which are greater than 60,000 that begin with an even number. All right. Now, we can have odd number at the start. Now, let's say I have only the number 7 at the beginning, and I can have any other number here apart from the number 7 at the end. I need to have one of these numbers, otherwise the number won't be odd. So I have 4 options here and only one option here to fill this space. Now again, I've selected 2 numbers, so I'll be left with 8, then 7, and then 6 numbers, because I really don't care about these numbers in the center. So I can actually fill this up this way. And this is the same way I can actually fill this up with 9 at the beginning, or 1, 3, 5, or 7 at the end. Again, I have 4 options here, 1 here, 8, 7, and 6. So you don't have to split this up. What you can do is just multiply this part by 2, and you can get rid of the one that we have done below. So this gives you all the odd numbers which are actually bigger than 60,000 and are actually odd as well. Right. Any other questions, anyone? I do have a permutation. I do have a question on arithmetic and geometric progressions, which is fairly challenging. So if any of you are actually keen on it, I can actually explain that part as well. Okay, let me share that question. Just give me a minute. Let me just try and search that question up and then I'll share it. All right, let me just try and share the question that I was actually referring to. Let's see how many of you can actually solve this one, just to see how good your preparation really is. All right, I expect you to try and solve question number 27. It's fairly challenging. Let's see if you can actually try and figure this out. Right, can we try and attempt this question, see if you can actually try and figure this out? Some of you have already taken AdMath exam, so if you want to try, you can as well. We're still there, Zad and Mustafa, sorry, Muhammad. All right, now let's try and solve this question, which is fairly challenging for most of you. So over here, he has given us a geometric sequence which has a term, the first term as a and the common ratio as r, sum to infinity is given to us as 76. So this is an information that we have to use. As second geometric sequence has a term, has the first term a and common ratio r cubed and sum to infinity as 36. So let's try and use the sum to infinity formula, which is u 1 over 1 minus r. That is for, let's say, the first sequence, right? This, let's say, is for the first sequence. And for the second sequence, it is going to be u1 over 1 minus r cubed. Now, in both cases, the sum to infinity is given. So in this case, in the first case, it's 76 is equals to u1 over 1 minus r. In the second case, it's 36 is equals to u1 over 1 minus r cubed. Now, you can rewrite u1 as 76 into 1 minus r, or you can rewrite u1 as 36 into 1 minus r cubed. Now, at this point, you can equate the two u1s and get something like this. Right? Now, this is a cubic equation that you'll have to use, or you'll have to solve using you'll have to solve using remainder and factor theorem, right? And the r value, obviously, since it's sum to infinity, has to be between -1 and 1, right? So anyone who has actually gotten an answer as 10 is obviously incorrect. So you can't possibly have a common ratio of 10 here. It has to be a decimal value. So now that we have gotten this up to this point, which is 76 into 1 minus r is equals to 36 into 1 minus r cubed, I'm actually going to try and solve this using remainder and factor theorem. So let me just try and share my whiteboard and then we'll continue with this question. So this is what we have, right? So at this point, you can simply try and rewrite this as 76 minus 76r is equal to 36 minus 36r cubed. You can rewrite this as 36r cubed minus 76r plus 40 is equals to 0, right? You can try dividing the entire equation by 4. You get 9r cubed minus 19r plus 10 is equals to 0. Is this it? Right, so you end up with something like this, which you can actually try and simplify or try and find out the root here. So I know I can clearly see r can be 1 as one of the roots. So 9 times 1 cubed minus 19 times 1 plus 10. This is 9 minus 19 plus 10 gives me 0. Right? So one of the roots or one of the factors is going to be r minus 1 of this equation. So I can rewrite the other factors as ar square plus BR plus C is equals to 36 R cubed, or let me just try and use a simplified one, which is 9R cubed minus 19R plus 10. So at this point, you can try using either synthetic division, or you can do long division to find out the values of A, B, and C, or you can try and use comparing the coefficients of the two sides to get the values of A, B, and C. So I'm just going to go ahead and use the comparing the coefficients method. So if I try and multiply AR squared with R, it gets me AR cubed, which should be equivalent to 9R cubed. So that means A must be 9. Now if I try and multiply -1 with C, that gets me negative C, which should be 10 as a constant value. So C must be -10. Now I need to figure out the value of B. For that, I can try using or multiplying BR with R. So that gets me BR squared plus minus AR squared is equals to 0R squared. 0 because there's no R squared coefficient on the other side. A I already figured out. So I get the coefficient of B minus A as 0. So B must be equal to A, which is 9. So the equation becomes 9R squared plus 9R minus 10 into R minus 1. Obviously, R cannot be 1 because it's a sum to infinity. So if the ratio is 1, it cannot be a geometric progression anyways. So now we just need to solve this equation to find out the two values of R. We have 9R squared plus 9R minus 10 equals 0. We can try and factorize it if possible. So I have 9 times 10, which is obviously 90. 1 times 90, 2 times 45, 3 times 30, 5 times 18, 6 times and 15. So I think 6 and 15 will work. We can use 9R squared plus 15R minus 6R minus 10 is equal to 0. Taking 3R as common, I get 3R plus 5 minus, you can take 2 as common. If I take 2 as common here, I get 3R plus 5 is equals to 0. I get 3R minus 2 and 3R plus 5 is equals to 0. R is equals to either 2 over 3 or R is equals to negative 5 over 3. Now this is actually not possible. The reason for this, for it to be not possible, is since you are trying to find sum to infinity, the value of R has to be between -1 and 1. So the only solution is R is equals to 2 over 3, which is the correct answer for this question. Right. So are there any other questions that you would want to ask or anything that you would want me to go through? Right, the difference between domain and range, domain is simply put the X value and the range is basically the Y values, right? Domain most of the time is actually given in the question itself, and range is something that you have to actually find out using the domain that is actually given. One of the common questions that you get asked in the exam is, let's say you're given a function f of x is equals to, let's say 3x squared minus 18x plus 7 for a given domain of, let's say, minus 3x to 2, right? The domain is already given. These are the values of x. So this is your domain. And you are required to find the range of this function. Find range. Now, obviously, since this is not a one-to-one function, you can't simply substitute the extreme values, minus 3 and 2, into this one to find the range. So what you need to do is try and rewrite this function in the completed square form. So for that, we need to find out its turning point. So we have to have it represented in this format. We need to find the value of h, which we can do as minus b upon 2a. So minus b is going to be 18 divided by 2 times 3, which is 6. So 18 divided by 6 gives me a value of 3. Now, obviously, we need to find the value of k. So substitute or take this value of 3 that you have and substitute it back in to the function. So you get 3 into 3 squared minus 18 times 3 plus 7. This is going to give you the value of k. So 3 squared is 9 times 3 is 27. 27 minus 54 gives you negative 27 plus 20 gives you negative 20. So this is what you get. Now, coming back to the domain, it's between negative 3 and 2. So obviously, if I try and draw the graph, the turning point is here, 3 minus 20. The graph will probably look something like this, with this point being 3 minus 20. But if you look closely, the domain that is actually given to me only begins from here and goes like this. So I need to find this value and this value. For this given domain, the function is 1-to-1. So I can simply substitute the extreme values for the range. So I can simply try and find out f of 2, which will be 3 into 2 minus 3 squared minus 20, which gets me minus 1 squared, which is 1 times 3 is 3. So I get negative 17, and f of negative 3, which gets me negative 3 times negative 3 is negative 3 times minus negative 3 is negative 6. Square it, you get 36 minus 20. 3 times 36 is 108. Subtract 20 from it, you get 88. So the range for this function will simply be, it's less than 88 and greater than negative 17. That is your range for this function. And this is one of the common questions that is actually asked in this AdMath paper. All right. So having done all that, I would highly suggest to all of you that you have an exam tomorrow morning. Get a good night's sleep. I think you have, all of you must have done really well throughout your term. So I would highly, highly recommend a good night's sleep. Try and be in bed by 11. I mean, whatever you have done is done. So you can't go back and change the course of history. In your case, I mean, the entire 3 years that you've actually put in the work. So just try and relax for the last few hours that you are left with. Try and make sure that you are well rested before your exam, because in the exam you would ideally want your brain to work. If 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 you're not well rested, your brain won't be able to think properly. So I would highly suggest that you uh, have a good night sleep, and I wish you all the best for tomorrow. All right. Thank you very much, everyone, for joining. Hope it was helpful for all of you, and hopefully I'll see some of you pretty soon. Thank you, and Allah Hafiz.